Hi there, welcome back to the channel. Now in this video I'm going to be explaining the anomalous expansion of water, or basically say anomalous behavior of water. What does anomalous mean? Anomalous is from the word anomaly, that is the abnormal. Okay, so abnormal behavior of water. Now what do we call the behavior of water abnormal? So this is it. On the principle of thermal expansion. Okay, now what happens is that as you increase the temperature of a fluid, as the temperature of a fluid increases, what you expect is that the volume of the fluid will also what increase. Why? Because the fluid is going to undergo what is called expansion. You expect that as you heat a fluid, or generally speaking, when you heat a fluid, the fluid will expand. When you heat a fluid, so I said that based on this principle, we know that as temperature increases, the volume of the fluid should increase. But with water, something strange seems to occur. The graph for every other liquid of volume of the liquid against temperature is such that as you heat the liquid from, for example, 0 degrees Celsius, you're going to notice as the temperature increases, you are going to notice that the volume will also increase. So the graph is going to look somewhat like this. Do you understand? It's going to be a curve, okay? So it's going to increase somewhat like this. So what happens is that the graph of water, when you have the graph of volume against temperature, when you heat water, is not like this, okay? It's different. Now, what is the difference, and why do we call it anomalous? So we know this is the graph for a normal fluid, but that of water does something. Now, when you heat water from temperature of 0 degrees Celsius to 4 degrees Celsius, here's what happens. Water tends to, instead of expand, it contracts. So remember, from the temperature of 0 degrees Celsius to 4 degrees Celsius, water contracts. What does contraction mean? Reduction in volume. This is expansion, this is contraction. So when you heat water from 0 degrees Celsius to 4 degrees Celsius, water will reduce in volume. So what does that mean? It means that after 4 degrees Celsius, water then begins to behave normally. That is, water begins to expand. Okay? From 5 degrees Celsius above, water begins to expand. But from 0 to 4, water contracts. Meaning that at 4 degrees Celsius, water is going to have its lowest volume. And remember that the formula for density is mass over volume. So if that's the case, then water will have its highest density. That is, the density of water will be highest density at 4 degrees Celsius. Why? Because the volume would have reduced maximally. So the density would, since the volume has reduced, then mass will be more. Think of it that way. Then the highest density of water is densest at 4 degrees Celsius. Keep that in mind. Water is densest at 4 degrees Celsius. Now, actually, what about going below 0 degrees Celsius? Now, if you go below 0 degrees Celsius, you cool it, okay? Water still contracts. Do you understand? Water continues to contract and contract. But the point is, when you increase from 0 to 4, you have a normal fluid should actually expand, okay, and increase in volume. But water does something anomalous, which is it contracts first, after which it does what? Expand. Okay, now if you now cool it down from 4 degrees Celsius, you cool it down back to 0 degrees Celsius, what's going to happen? If from 0 to 4 is contracting, then from 4 to 0 you are cooling. You know, when you cool a fluid, normally it should be contracting. But when you cool water from 4 degrees Celsius to 0 degrees Celsius, this guy will actually expand. Okay, this guy will expand. Then if you now go below 0, it begins to contract again, continues to contract again. So the point with anomalous expansion of water is such that from 0 to 4 degrees Celsius, water contracts, and from 4 degrees Celsius back to 0 degrees Celsius, water expands. Is that clear? So that the graph of temperature against volume against temperature is going to, for water, is going to look somewhat like this. So volume against temperature. So if temperature is here 0, 1, 2, 3, 4, 5, 6. So what will happen is that the volume is going to, when you heat it, it's going to contract, meaning that the volume will reduce up to this 4 degrees Celsius, after which it will begin to increase. Is that clear? But on the other hand, if you now plot the graph of density against temperature, density now against temperature, what will happen is that the density will be maximum. So if it is 1, 2, 3, 4 still, and above that, so you are going to notice that the density of water will increase and be maximum at 4 degrees Celsius, after which it begins to reduce. Is that clear? So that is about anomalous expansion of water. Do well to subscribe to the channel and click the bell notification to get notified whenever I drop a new video. God bless you.